So welcome to this latest video on 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of graph transformations. Now once we've gone over the basics and given you some notes for you to keep to help you with your revision, we'll go through some exam style questions which if you're wanting to have an attempt at before watching this video or while watching it, all you need to do is just simply click on the link in the description below. Now, just like an object can be translated, reflected and or enlarged, a graphical curve or function can also be mathematically transformed. The type of transformation that is performed is dependent on what you are doing to the equation of the function or the actual curve. Now, before being able to define a graphical transformation, you must first be able to decide whether you are doing something to the function or to the x. Now, this really does depend on whether the transformation is going to affect the x ordinates or the y ordinates. Now, as an example here, so if we start with the original function, which is y equals f of x, and if I just highlight just that there, then what we're going to do is we're going to decide whether we are doing something to the function or whether we're doing something to the x. Now, this isn't actually going to be part of any of the working out that you do to decide or perform a graphical transformation, but it's certainly going to help you decide what it is you're actually going to do. So whether it's going to be the x ordinate that's going to be affected or the y ordinates that's going to be affected. Now in this, our original equation is y equals f of x. So this is just a generic function. We don't need to worry about whether it's a parabola or a cubic graph or a S-shaped graph or even a trig graph. We're just depending on whether we're doing something to the function or whether we're doing something to the x. Now, if you can see f of x, now y is our subject, so our function is the f of x part. Now, if you can still see f of x in all of its entirety with no sort of edit or anything that's happened to it, then you're going to be doing something to the function. So for example, with question 1, if we had f of x plus 3, because you can still see the f of x, the original function, this is something that's happening to the function. Now in example 2, here you can see that my x has been altered, so this is an example of when we are doing something to x. For question 3, you can see here that I can't see f of x, I can see f of 2x, so here we're doing something to the x. For question 4, here we can still see the f of x, and that's not been touched, I've just got multiplying it by 2. So in this one here, we are doing something to the function. In number 5, although it looks like f of x, actually it's f of minus x. So here I'm doing something to the x. Here I've got f of x minus 4. So again, I'm going to be doing something to the x. In example 7, I've still got that f of x. So here I'm doing something to the function. And in this last example, for question 8, I've got f of x minus 3 plus 7. So here I'm doing both. Now at GCSE level, it's unlikely you'll ever get a question involving both, but it does get tested or get asked at A level or further on from GCSE. So now let's have a look at another example. So this time what we've got is we've actually got an equation. So here we've got y equals x squared. So here our function is x squared. So when we're forming a transformation, what we want to look at in the equation is, can I still see x squared? Or is there something being altered to the x or something being altered to x squared? So again, looking at number 1, you can see that I've still got x squared and it's not been touched. So that is something that's happening to the function. For question 2, I can't see x squared, but I can see x minus 1 squared. So there we're doing something to the x. For question 3, you can still see the x squared. So this is something that we're doing to the function. Here, I can't see an x squared, so that's where we're doing something to x. For question 5, we can't see an x squared because, again, we've got brackets. And so here we're doing something to x. Question 3, I can see an x squared, so that's going to be doing something to the function. Question 7, here we're doing something to the x. And in question 8, here we're doing something to the function because I've still got that x squared part. Now you might be asking, well, where does this all come into play? Now, working with a drawn curve. So with these types of questions, this is where you are given a graph and you need to sketch what the image is going to be with the original equation being the object to see where it's going to be. Now this question is quite different to when you're dealing with coordinates, which the next video will look at when you're transforming a graph but paying more closer attention to the coordinates. Now, depending on whether the transformation is doing something to the function or the x will depend on what you need to do to draw the image of the curve that is to be transformed. Now, in this section, a typical question would be where you're given a drawn curve, whether it be a parabola, a cubic graph or a trig graph, or just a random curve that's labelled y equals f of x, and you need to draw a new curve based on a transformation. Now, once you've decided that what you're doing to your equation is you are affecting or doing something to the x, this is basically going to affect the x ordinates. So let me just make a little note of that. So this basically affects the x ordinates. Now, we'll pay closer attention to the coordinates of a graphical transformation in our next video. This is just about drawing. Now, again, one thing I would strongly recommend that you do, that if you are making notes, that you make a copy of this particular table. Now, this is one of two, so this table only applies when you are doing something to the x. Now, once you've established that you're doing something to the x, the next thing you need to look out for is, are you adding, subtracting, multiplying, dividing, or changing the sign? Now, when you are doing something to the x, now one way of remembering this is it's kind of the opposite of what your instincts is telling you. Now, when you're adding something to the x value, then you automatically think, well, if I'm adding something to the x ordinates, I'm going to be shifting it to the right because that's where my positive numbers are, if you think about your number line. However, when you are doing graphical transformation, it's kind of like the opposite of what you think. So here, when you're adding something to a function, so if you have something that looks like f of x plus a, so like you're adding 2 or adding 3 or adding 4, then basically what you're doing is you're actually going to shift it to the left by a places. And likewise, if you are subtracting from x by a, then actually what you're going to be doing is you're going to move it to the right by a places. So again, if you had x minus 4, you're going to be moving it 4 places to the right. Then when you are multiplying x by a, then actually what you're going to be doing is you're actually going to be squashing the curve inwards towards the y-axis, and that kind of stretches as if, so imagine you've got the equation or the set of axes or the graph paper on either sides of your open palms, and imagine that you are pushing them, your hands closer and closer together, so you're kind of squashing the graph. Now, when you're dividing x by a number, then actually what you're going to do here is you think, oh, I'm going to make the numbers smaller because that's what you generally do when you're dividing. However, here what you're going to do is you're actually going to stretch the graph outwards. So it's actually going to go in that direction. So if you imagine that your hands are holding on to either side of the graph, what you're going to do with your hands is actually move them further apart. So you're actually going to push them outwards. And when you are changing the sign of x, then this is basically going to be a reflection on the y-axis. So imagine that you've got a mirror line on the y-axis and you're simply going to reflect the curve on the y-axis. Now, when you are doing something to the function, now this is where common sense actually does prevail. So this, when you're doing something to the function, this is actually going to affect the y ordinates. And again, we'll talk about more about the y ordinates in the next video. Now here, when you are, and again, I'll probably definitely recommend that you make a note of this table. So when you know that you are doing something to the function, well, when you're adding, you're basically going to shift the graph upwards, and again the x ordinates will stay the same, but you're just going to shift the graph up. If you're subtracting, you're going to shift the graph down. When you're multiplying, this time what you can do is you're going to stretch the graph upwards and downwards. So imagine that you've got hold of the graph both on the top and the bottom, and then you're going to stretch the graph so your hands are moving further away from each other. And when you're dividing a function by a, then that is where you're squashing the graph closer parallel to the x-axis. And when you're changing the sign of the function, now here, this is when your mirror line is the x-axis. So where you're reflecting it vertically rather than horizontally like we were doing when you're multiplying, when you're changing the sign of the x. So now let's have a look at some example questions taken from some past papers. Now, if you're wanting to have an attempt or to download these questions, all you need to do is just click on the link in the description and it should load up. But these questions are taken from past exam papers. So looking at question 1, it says on the grid, draw the graph of y equals 1 plus sine x for all the values of x between 0 and 360 degrees. The graph of y equals sine x has been drawn for you to help. So looking at this, what we've got to do is looking at this particular equation. So let me just load that up. So here we've got our original equation, which is y equals sine x. And as you can see here, what we're doing is we're doing something to the function. And what it is we're doing to the reason why we're doing something to the function is because I can still see sine x. And what I'm doing to the function is adding 1. Now here what you're doing when you're adding 1 is you're basically going to shift the graph up by 1 place. So if I look at the points on this graph, the key points of y equals sine x, which are these points here, and what I'm going to do to those pink points is basically just shift them up 1 square up. So if I shift them 1 square up, what they then look like is they're going to look like this. And what I then need to do is just carefully join those points up, and it should look something like that. So as you can see, each of the graph has basically been shifted up 1 place up. Then moving on to question B, it says on the grid, draw y equals 2 sine x. And again, original graph has been drawn. So our original graph is this, and this is our transformed. And as you can see, I can still see a sine x. So here I'm doing something to the function, and what I'm doing to that function is I'm multiplying by 2. Now multiplying by 2 basically stretches it out vertically. So again, if I pick my key points of the original curve, which I've just done in pink, and this time what I'm going to do is I'm going to stretch them so they're twice as big, or basically multiply the y ordinates by 2. So 0 times 2 is 0, 1 times 2 is 2, that's 0, then minus 1 times 2 is minus 2, and then I've got 0. So what this graph then becomes is it becomes something like this. And as you can see, what I've done is I've stretched it out going in a vertical direction. Then moving on to question 2, it says the graph of y equals x squared is transformed by the vector of 0, 2. Write down the equation of the transformation of the transformed graph. So here, as you can see, I've moved the graph up by 2 places. So that's going to be doing something to the function, and if the original function is x squared, then all I then need to do is do x squared, and because I'm shifting it up, I'm going to add 2. If I was shifting it down, it'd be minus 2. If I was shifting it to the right, I'd be taking away that number by x, and if I was moving it to the left, I'd be adding some x to a number. Now moving on to B, it says the diagram shows the graph of y equals x squared. On the same graph, sketch x plus 1 squared. And so this is where I'm doing something to the x, and I'm adding 1 to the x. Now when you're adding, you're basically moving it to the left by 1 place. So here, all I'm going to do is I'm just going to imagine where 1 is going to be. So I'm going to imagine 1 is there. And all I'm going to do is just make it look like I've shifted that graph so it's at 1. So imagine like 1 is your mirror line. And I'm just going to write a little minus 1 there just to show that I've shifted it 1 place to the left. Then moving on to question 3, it says on the axes below, sketch the graph of y equals x cubed. Now y equals x cubed is a cubic graph, and so it's going to look something like this, where the point of inflection is at the origin. Now the next question then says on the axes below, sketch the graph of x cubed plus 8. Well, when I'm adding 8, so here I'm doing something to the function, and I'm adding 8, so that means I'm going to shift it up 8 places. So that key point at the origin is now going to be here. I'm just going to mark that with the number 8. And what I'm going to do now is just replicate that curve that I'd just done before, and I'm going to draw my curve so it looks like this. And that should be fine. But as long as you've elevated your graph going upwards, and that point of inflection is just there, is above the x-axis, you can mark it with the number 8 where it is, where it intercepts the y-axis, and that should be good enough to get you your 1 mark. Then moving on to question 4, it says here is a graph of y equals cos x, and in parts of A and B, the graph of y equals cos x is shown by the dashed line. So here what I need to do is I'm doing something to the x, and I'm subtracting 90. So that means that I'm going to be shifting it that way by 90 degrees. So here, if I look at the key points on this cos graph, what I'm going to do is I'm going to shift it to the right by 90. So this first point is now going to be here. This point here is now going to be there. This point here is now going to be there. This point here is now going to be there. So then what I then need to do is just simply join those points up in which it looks something like that. Then for part B, here I'm doing something to the function because I can still see I've got cos x. So here I'm doing something to the function and I'm adding 1. Now adding 1 to the function, don't know what's happened there. Adding 1 to the function means that I'm going to shift it up by 1 place. So again, highlighting the key points. And what I'm going to do to each of those points is just move it up 1 place. So it looks like this, and then all I need to do is just mirror the shape. That's actually really poor, so let me try that again. And what you should have is a nice curve graph that looks something like that. It then says Rita tries to draw the graph of y equals cos of minus x. Here is her graph. Give a reason why Rita's graph is wrong. Well, y equals minus x. Well, when you're changing the sign of x, so changing the sign of x, if you look back to the table, means that we need to reflect on the y-axis. Now what it looks like is what Rita has done is she's reflected it on the x-axis, so that's where she has made a mistake. So she has reflected on the x-axis, and the correct answer should have been a reflection on the y-axis. So something along those lines would have been good enough for that 1 mark. Moving on to question 5, it says on one of these graphs 1 plus sine x, well, let me read that again. One of these graphs of y equals 1 plus sine x for 0 to 360, circle the letter above the correct graph. Now for this, what we're doing is we're basically adding 1 to the function. So we're basically shifting the sine graph 1 place up. And the function is sine x. Now, if you think about what sine x is, sine x starts at 0 and looks something like this. So that's going to be 0, 1, and that's at minus 1. So I'm looking for a graph that starts at plus 1, which is this one here. So A does, and that's the only one that does. So then the correct answer is going to be A. Moving on to question 6, it says here are sketches of 2 graphs. The graph of y equals x squared minus 1 is translated 3 units to the left to give graph A. And it says the equation of A is written in the form of y equals x squared plus bx plus c. Work out the values of b and c. So here what we've got is we've got x squared minus 1, and this is going to be translated 3 units to the left. Now 3 units to the left means that we're going to change x with x plus 3. So what we're going to do is we're then going to swap x in y equals x squared minus 1 with this instead. So what the equation is going to be is y equals, rather than using x, I'm going to use x plus 3 squared, take away 1. Now what I then need to do is I then need to expand this equation out. So what I've got is I've got y equals x plus 3, and I can't forget that minus 1. And then from this I've got x squared plus 6x plus 9 minus 1. And that gives me a final answer of y equals x squared plus 6x plus 8. And so here, looking at my b value, well, that's going to be 6, and my c value is going to be positive 8. It then says that the graph of y equals x squared minus 1 is reflected in the x-axis to give graph b. Work out the equation of graph b. So here, if we're reflecting along the x-axis, then basically what we're doing is we're going to change the sign of the function. So what this then looks like, well, if the function is x squared minus 1, so here what we're then going to have is x squared minus 1, and what I'm going to do is going to put a minus in front of it because I'm changing the sign of it all. Now if I expand the brackets, then what that then becomes is minus x squared plus 1. So the equation then is going to be minus x squared plus 1, or you could write it as 1 minus x squared. Then moving on to question 7, it says curve P has the equation of y equals 2 lots of x minus 1 squared minus 5. Curve Q is a reflection in the y-axis of the curve P. Work out the equation of curve Q. Give your answer in the form of y equals ax squared plus bx plus c. Now, a reflection in the y-axis is basically going to be where we change the sign of x. Now if we change the sign of x, then what the equation then looks like is y2, and then we've got minus x minus 1 squared minus 5. Then from this, what we've then got to do is expand the bracket. So I've got y equals 2 lots of minus x minus 1 minus x minus 1 take away 5. Then expanding the brackets out, I'm just going to put square brackets here. We get minus x times minus x is x, positive x squared. Then we get positive 1x plus 1x plus 1 minus 5. Then neatening all of that up, I get y equals 2 lots of x squared plus 2x plus 1 minus 5. And then multiplying everything in the brackets by 2, so I get 2x squared plus 4x plus 2 minus 5, and then gives me the final answer of y equals 2x squared plus 4x minus 3. Then moving on to question 8, it says the graph with the equation of y equals x squared is translated by the vector of 2, 0, and it says circle the equation of the graph. Well, here we're shifting it up 2 places, so that then is going to become x squared plus, oh no, sorry, we're not shifting it up 2 places. We are shifting it to the right 2 places. So then we're doing something to the x because we're changing the x ordinates. So common sense thinks that you're moving it to the right, but actually we're moving it to the left. So it's going to be x minus 2 squared, and that is option number 1. Then moving on to our last question, it says here is a graph of y equals f of x. The graph has a turning point of minus 1, minus 4. On the grid, draw the graph of y equals x squared minus 2. So here we're affecting the x ordinates and we're subtracting 2. So here what that means is we need to shift it to the right 2 places. So I'm going to pick this point here, I'm just going to shift it 2 places to the right, so it's here. This point becomes there, and this point here is going to become there. So what I then need to do is just join these points up with a smooth curve and then just continue it. And so it should look something like that. Then for question B, it says the graph of y equals minus 3x squared plus 4x minus 5 is reflected on the y-axis. Work out the equation of the reflected line. Now if it's reflected on the y-axis, what we're doing here is we're changing the sign of x. So what that then becomes is y equals minus 3, and it's going to be minus x squared plus 4 minus x minus 5. Now if I simplify all of this, we get y equals, now it's still going to be minus 3, but minus 3 squared is positive x squared. This then becomes minus 4x minus 5. So my final answer is going to be y equals minus 3x squared minus 4x minus 5. And in fact, that's not actually our last question. So looking at question 10, it says the curve with the equation of y equals x squared minus 5x plus 2 is reflected on the x-axis. So with this, what we need to do is when we're reflecting anything on the x-axis, what we need to do is change the sign of the function. So what this then becomes is y equals minus, and then we've got x squared minus 5x plus 2. Now if I change the sign of everything that I've got in there, I've got to have minus x squared plus 5x minus 2, and that is this bottom left hand option. Now moving on to question 11, it says the graph of y equals sine x for 0 to 360 degrees is shown. And if I scroll down, it says on the grid, draw the graph of y equals 1 plus sine x, and they've sketched the original graph for us. So this is where we're adding 1 to the function. So add 1 to the function. So that means that basically we're going to shift it up one place. So again, looking at the key points, this 0 becomes plus 1, this becomes 2, this point here becomes there, this point there becomes there, and this point here becomes there. So what we then look, what it looks like is it's going to look something like that. Then moving on to B, it says on the grid below, draw the graph of y equals sine, and then it's x plus 90. So for this, what we need to do is when we're adding 90, we need to shift it to the left, and it's going to be by 90 degrees. So this point here is now going to be, well, if I just highlight all the key points. So this point here is now going to be there. This point is now going to be there. This point is now going to be there. And this point here is now going to be there. And the last point is now going to be here. So then sketching this graph, what it looks like, it's going to look something like that. Then moving on to our very last question, it says this graph shows a sketch of y equals x squared. On each of the grid, the graph of y equals x squared is shown by a dashed line, and the question is asking for the first one is to sketch y equals x squared plus 5. So here what we're doing is we're adding 5 to the function, and when we're adding 5 to the function, we need to move it up 5 places. So this point here, which is the peak, is now going to be at this point here, and everything else is just going to get shifted. So what it then becomes is something that looks like that. Doesn't need to be accurate, just needs to be the correct shape. Then for B, it then says y equals x minus 3. So here we're taking away 3 from x, away from x, which basically means we're going to shift it to the right 3 places. So this point here is now going to be at 3, 0, and all the other sequential points are just going to be shifted 3 places. So this coordinate here is now going to be 3 places to the right, so that's going to be there, and this point here is now going to be 3 places, which is there. So what it then becomes is something that looks like that. So basically what you want to do is just sketch to show that you've moved it 3 places to the right, and that is our very last question in this video.